This is old review theoretically. This is the type of problem you learned first how to do a couple years ago. Would have been doing some again last year. General idea here, in case you're needing just a little bit of a starter, try to get your exponential by itself first. So in other words, try to isolate this part of your equation first, and then we can go from there to finish solving it out. Now, once we've gotten the exponential by itself, now we need to solve the exponential. What formula, which function do we use to solve an exponential? Yeah, it's logarithms. And so you're going to take what you have here and change it into a logarithmic form. And then once you turn it into a logarithm, we can solve it from there. In order to calculate the log base 3 of 64, we have to use change of base formula. That's where we do the log divided by log. And so it's going to be log 64 divided by log 3. A little side note here, I happen to write it as log 64 over log 3. You also could have done it as natural log 64 over natural log of 3. As long as you use the same log form on both the top and the bottom, it will work. But either way will be fine. But that's the calculation we now do. So we do log of 64 divided by the log of 3. That gives us an answer of about 3.78. Then we can finish solving it by simply adding the 1 to both sides. And we get a final answer of about 4.79. All right, continuing on with our theme today of practicing our logarithms, this is the properties of logarithms. Now, these are all rules you should already know. Is it possible that maybe you've gotten rusty on 1 or 2 of them? Yeah. And so if you're looking at these and you're being like, oh, dude, I don't remember those, I would write really fast, putting these into your notes so that you can look back on them as we go forward, because you're going to be using these today and pretty much for the whole rest of the year. Now, to put those rules into practice, we're going to start by expanding these 3 logarithms. And yes, we always simplify if we can. So, taking a look at that first one. Actually, before we do it, write them down and take like a minute. Try expanding each one on your own first. That way you have a chance to process them through before we get too far into it. All right, so for that first one, we first decide which rule we're going to use. And in this case, what jumps out to me is the fact that I am actually multiplying inside of my logarithm. That tells me that I'm going to be using this rule, the one that starts with the m times n on the inside. Notice that tells me that it's going to become addition of logarithms. And so I write out my log base 5 of the 25, the first part that was multiplied, plus the log base 5 of x. All right. And we've expanded it. So expanding is done. Now we need to look and see, can it be simplified? Is there anything here that can be simplified? Well, log base 5 of x is just log base 5 of x, but the number part here. I don't want to have to mess with a decimal, but I would want to turn it into a whole number if it is one. Is log base 5 of 25 a whole number? Yes. Because remember, when you see log base 5 of 25, basically what it's saying is 5 to the power of what equals 25. Well, that's one we know. 5 squared is 25. So that just must equal 2. So since it simplifies down to a nice pretty whole number, we do that. And this is now simplified and therefore done. All right, we then go on to the next one, log base 3 of 9 over x. What jumps out to me here is the fact that I am dividing on the inside of my logarithm. That tells me to be using this rule, where I turn the division into subtraction of logarithms. All right, so now I'm just following that rule. So I'm going to do log base 3 of the top minus log base 3 of the bottom. And yes, order does matter here because it's division and subtraction. All right. Now one last step. Now that we've done the expanding, now we look to see if we can simplify it. The one that could possibly be simplified is the one with just numbers in it, log base 3 of 9. is that one that we can know. In other words, 3 to the power of something equals 9. Is that a nice, pretty number? Yep, sure is. Because 3 squared equals 9. So, answer's 2 there. And so we've simplified again. All right, last one. What I notice happening inside of my logarithm here is an exponent. Well, an exponent on the inside of my logarithm uses this rule, which notice means that my exponent is going to be pulled outside of the logarithm. As you're going to be seeing later this year, that little fact, that little bit of a rule there, that property of logarithms, can be used in all sorts of ways. It's going to be one of the big themes of the year. This is a really important rule to make sure you have down. Nudge, nudge, wink, wink, right? Make sure you learn it if you don't already. All right, so I'm going to be doing the same thing with this one up here. I'm going to take that exponent and I'm going to pull it out front. So that turns into x times log base 4 of 64. We then look to see if we can simplify it at all. Well, I do have log base 4 of 64 here. Would that equal a nice, pretty number? Yeah, actually it does. Because log base 4 of 64 is 3. So this whole thing is really just x times 3. Or, if we want to make it pretty, 3x. And isn't that a whole lot easier to calculate than log base 4 of 64 to the power of x?